good day everyone. My name is Ellen Jane D. Barasolia and I will be reporting the basic principles of science. Now, before we go further, here is our learning objectives for today. After the discussion, we will be able to define the basic principles of science and differentiate the basic principles of science. Now, here we have the 7 basic principles of science that we will get to know today, which are empiricism, uniformitarianism, parsimony, uncertainty, repeatability, the proof is elusive, and lastly, testable questions. Now, let's go ahead and discuss each of the basic principles. Let's start with empiricism. This principle believes that knowledge is acquired through sense experience. It states that we can learn about the world through careful observation of empirical, which are the real and observable phenomena. Experiences and observations are taken into account to justify the beliefs and claims regarding knowledge. The knowledge we hold can be best justified in light of the evidence that we receive from our senses. We therefore can know something if we can justify it with the respect to, for example, what we see, we hear, and feel about the world. We can know something or can expect to understand fundamental processes and natural laws if we can justify it through what we can experience through our senses. Next, we have uniformitarianism. This is the name given to the idea that natural processes behave more or less in the same way today as they have throughout the past and will continue to do so in the future. Although it can apply in any science, it was a cornerstone for the development of the science of geology. The significance of uniformitarianism helps us understand much about how geologic features such as valleys, sedimentary rocks, and mountains came to be by observing the events of the present day. Uniformitarianism gave us the tool to interpret the geologic past. In fact, geologists sometimes summarize the concept into the phrase, "The present is the key to the past." The third principle is parsimony. This is the principle in science where the simplest answer is preferred. This principle is also known as Occam's razor, as it is attributed to the early 14th century English nominalist philosopher William of Ockham, who proposed that in a given set of equally good explanations for a given phenomenon, the correct explanation is the simplest explanation. So it is called Occam's razor because he shaves his explanations down to the bare minimum. His point was that in explaining something, assumptions must not be needlessly multiplied. And in particular, for the purposes of explanation, things not known to exist should not, unless it is absolutely necessary, be postulated as existing. So we have to bear in mind that under this principle, it favors simple explanations over complex ones that do not give deeper meaning. So we have to keep it simple. The fourth one is uncertainty. Theories are always open to correction and improvement. As knowledge changes, new evidence appear, and this new evidence can invalidate predictions and even modify well-accepted understanding, so these causes for the change of explanations or the theories with new evidence. So under this principle, approaches are based on current evidence that should be tested on additional evidence, with the understanding that new data may disprove the best theories. The fifth one is repeatability. This is an experiment performed to evaluate how repeatable your results are under a set of similar conditions. In other words, this principle is a way of measuring precision and to produce that exact same result from an experiment. It's a way to verify that results are true and are not just chance artifacts. Essentially, the trial should be conducted the same procedure using the same materials and measuring instruments under the same environmental conditions to collect repeatable results. The significance of repeatability in science is to back up independent verification and to show that findings are correct and transparent. The sixth one is the proof is elusive. We rarely expect science to provide absolute proof that a theory is correct because new evidence may always undermine our current understanding. So it is uncommon to have science bring out absolute answers as things may change over time, which makes prediction enormously difficult as new and different knowledge produces new evidence and may introduce some possibility that hadn't even happened before. Even evolution, the cornerstone of modern biology, ecology, and other sciences, is referred to as theory because of this principle. So the most that public policymakers should expect from the world of science is a consensus among the experts that the evidence truly points toward the conclusions that should, for now, be accepted until someone with sound credentials and new evidence can show that the consensus was probably wrong. So under this principle, we have to remember that scientific interpretations are always conditional and there's no absolute truth in science due to the varying degrees of uncertainty, and acceptance of a theory is always conditional. The last principle is testable questions. Testable questions are ones which can be answered through experimental inquiry and observation of the natural world. They are the one that can be answered by hands-on investigation or designing and conducting an experiment. Therefore, questions that cannot be answered by direct observation or by evidence gathered through experimental inquiries are not testable questions. And we have to remember that testable questions can be answered using scientific methods such as research, field study, and experimentation. Testable questions include also what will be varied or changed, and what the impact that changing the variable is expected to have. So it's all about changing one variable to see what the effect is on another variable. So this means, in other words, that testable questions are always about changing one thing to see what the effect is on another thing, to be able to test whether the theory is correct or not, and if the results can be testable based on observable facts. That's it for my report. Thank you everyone for listening. Once again, maayong hapon sa tanan, and naimbag nga malam kada kayo amin sa mga Ilocano diha. Bye!